Hey AP Physics students, just a couple of quick hints about how to start out the first assignment problems. That'd be number 28 and 36. And hopefully this will give you a little bit of help starting. If not, you can always come in and ask me. On number 28, as you look at this, and most problems that have any significance, you'll have a couple of steps. So on this one, there's a drag racer starting from rest, a parachute then slows down. So there are a couple of different things that happen here. My suggestion is almost always to try to write the knowns and unknowns here. What you'll discover on number 28 is that it speeds up from rest. So that's a V1 of 0, eventually getting to a different velocity, which is useful to discover. And let's look at the knowns and unknowns. So the V0 equals 0. The V1, which is the velocity at the end, is something we wish to find out. There is a displacement which we typically call the delta x, or possibly just call it x1 at the end of the first time, and that is 402 meters. And of course the acceleration is given to us here of 17.0 meters per second squared. So suggestion to start it out. There is a formula, V1 squared equals V0 squared plus 2a delta x. So maybe you want to call this delta x up here. And when you solve for that, you will discover what the V is at the end, which will be useful in the next section. So there you go for number 28. Hopefully that's a little bit of help. Now, number 36 is the challenge. Notice the double stars. Well, double stars mean it's kind of double hard. However, it basically just means you need to use a few steps here and possibly some of the mathematics that you're used to. Okay, so let's look at how this one works. So we have on number 36, if you'll look at number 36, you've got a 100-meter dash. Now the problem with this is the 100 meters is separated into two different parts, as you might expect, accelerating and running at a constant speed. So for accelerating motion, you have a formula that is x equals v0t plus 1/2 at squared. So that's accelerating. Okay? However, when you go a constant speed, you have basically then just delta x equals the velocity times time. So those are two formulas that that relate to the same circumstance here. So in this, I guess the hint I want to give you to start is you're going to use both of these formulas at the same time and basically solve them simultaneously. The time for this whole thing to happen is 12. So you might call this an x1 for the first time. So this could be, you could consider this x1, and then really this drops away. And then this you could call x2 for the distance it travels when it's going at constant velocity. A couple of more hints to get you started. There would be a couple of times. T1 is the time when you are accelerating. Okay, so, but T2 is 12 minus T1. All right, so that's what you have here. So basically what I would do to start, and then I'll let you go from this, a couple things. First of all, you would realize that this x2 is going to be, so if you could write this as x2 equals the velocity. Now recall that when something accelerates, the acceleration is the velocity change divided by time. Well, since it's starting at rest, this velocity change would just be v. So the acceleration, so the velocity would be the acceleration times the time, t1, okay? So that's the velocity it has at the end. But you'd multiply it by 12 minus t1, Remember, 12 minus t1 is the t2. So the x2 is the velocity you picked up times the time. Now, so that would be useful there. You'll get two different distances then. The 100 is equal to, oops, I'll get that so you can see better. The 100 is going to be equal to x1 plus x2. That is the total distance. So you would add those two together. I would say the 100, which is x1 plus x2, is equal to the x1, which is the 1/2 a t1 squared, plus the x2, which I've mentioned there to be, so you can see this above here. So x2, where you can get this. Now, it involves enjoyment like the quadratic formula, and I think this would be sufficient to stop right here. Good luck with the problem.